By popular demand, your complete guide to fitting a Hemera to an Ender 3. The Hemera is an all-in-one stepper motor, extruder and all-metal hot end, and it's the latest and greatest from E3D. There's a lot of hype around this product and I've had a lot of requests to make this guide. I'm going to be fitting this to a stock Ender 3, and at US $130, it's a fair proportion of the printer cost. Some people might think this combination is too expensive, but please remember the best solution is the one that works for you. There are a fair few steps in this guide. Most of them simple, but to help I have everything timestamped in the description. I have to thank two of my patrons, Jan and Brian, for giving me pointers before I started. And for Brian, he even posted a GitHub page, which is linked below with his advice for this conversion. Even with this, I had to print a wide variety of parts until I found the best combinations for mounting, but hopefully that makes it easier for you following along for this video. There's a lot to get through, so let's start with an overview of the product. First things first, the name of this product used to be the Hermes, but is now the Hemera. The Hemera is the latest and greatest from E3D. They had previously set their standard with the V6 hot end, and now this new model has a range of great features. Firstly, it's dual drive, just like a Bondtech extruder. This is nice and visible on something like a CR10S Pro, and it means there are two hobs gripping the filament from both sides, and as it says here, it has up to 10 kilograms of force. Only two bolts to see inside, and we can see the two meshing drive gears ready to go. The filament tension arm is also adjustable. One of the main innovations is a custom NEMA 17 stepper motor inbuilt to the design. And we can see this here with the output shaft having the cog in place. This allows the Hemera to be a lot more compact than an equivalent design, in this case the BMG dual drive extruder with an E3D V6 hot end. For comparison, here is the Hemera mostly assembled with the integrated stepper, dual drive, cooling fans and hot end, all packaged more tightly and much smaller than before. The mounting system has been changed to T-slots, and that makes it compatible with mounting accessories. And for me, one of the coolest things is this heatsink here, developed with computational fluid dynamics to provide optimum cooling and blowing all of the air away from the bed and hot end. What I'm testing here is the 1.75mm direct drive kit, and it does come with a lot of hardware, but it's worth noting that additional hardware was required to mount cooling fans and other essential components. There's quite a bit to get through to get this installed, so we're going to approach it in steps. The first being to assemble the Hemera kit off the printer. And to help us, E3D has an illustrated guide which is linked in the description. We start with the heat break and the heat block, and we screw it in until the end of the thread is more or less flush with the top of the heat block. This part of the assembly can be adjusted later, so it just needs to be fairly close for now. After this, we take the nozzle and we screw it in until it meets the end of the heat break finger tight. Heat compound paste is included and we squirt it onto the thread of the heat break, not too much. Here I think I had just about the maximum, because when I screwed it into the main body of the Hemera, there was none oozing out at the end. Once again, this is only going to be finger tight. We can also change the orientation of the heater block later on when we do our final tighten. The instructions say to check for a coupler. Mine's already in place, so I can insert the PET FE tube that will be cut down later. Next up, we take our thermistor cartridge, slide it into the smaller hole, then we employ the M3 grub screw to hold it in place, but you definitely don't want to over tighten it and crush it. The heater block inserts from the same side. We try to center it, and then there's a specific bolt to also hold that in place. This one can be a lot tighter. The heatsink cooling fan is next. It's held by only two diagonal corners with screws that also shouldn't be too tight. They're self-tapping. Check afterwards from the side to make sure the fan is not bowed. The final step is to plug in the extension wire for the thermistor. Some of these parts will have a final tension later on, but for now we are done. Onto selecting and printing the adapter pieces needed to mount this extruder to our printer. There's quite a bit of variety, starting with the official files from E3D. This consists of A and B mounting parts as well as a fan duct for the stock 4010 fan. I did try these, but they didn't work very well because some parts were designed to be just one layer thin. In this system, part A bolts onto the carriage, the Hemera bolts onto part B, and then part B bolts onto part A. I then found this remix that has thicker parts, but otherwise adopts the same system. Part A onto the Ender 3 carriage, and then Hemera onto Part B and Part B onto Part A. This is what I'll be showcasing in this video. But what if you're running auto bed leveling? Joe from 3D Maker Noob has this really simple and elegant one-piece solution with a mount for a BL Touch. The single piece bolts straight onto the Ender 3 carriage, and then the Hemera bolts onto that, but the trouble for me was it only used 3 of the 4 mounting points, and in my opinion it had a little bit too much flex. Apart from this, it's definitely my favorite, and there are remixes available for the Easy ABL. It should be noted that the remix from Minisalt also has a BL Touch mount that puts it on the right hand side instead. For the stock part cooling fan, you're meant to use the E3D duct, except don't bother because there's no easy way to print it without support. The height is not adjustable, and for me, it sits far too low. Instead, I'm happy to pass on Brian's recommendation of this part cooling fan duct here. There's a mounting plate that provides adjustable height control. If you've upgraded to a bigger 50-15 part cooling fan, it'll fit straight into the duct as is. However, if you've still got the standard 40-10 blower fan, there's an adapter included in this thing here. It then slots into place before accepting the stock part cooling fan with the duct in the same position. This duct is tested with CFD and ducts to either side of the nozzle, although the wiring for the hot end is pretty tight. Once you've selected and printed your parts, we can move on to physically installing the Hemera. And again, E3 has a pretty reasonable guide which is linked in the description. We're going to start by removing the 2 bolts on the left and the upper side of the hot end cover, and once both are out, we're simply going to push it to the side and out of the way. Next, we're going to remove the 2 bolts holding on the hot end to the carriage, and once these are out, we're going to let it dangle and move the whole lot out of the way so we can access the carriage more easily. Before you undo anything, pay attention to the V-roller bolts. The top 2 face the back of the machine, whereas the lower one faces the front. You can now remove all 3, and every time you get one off, put it aside on the table but with the nut finger tight on the end to ensure the order of the component stays in place. We can now start to put it back together, and we start by taking the printed part A and aligning it with the holes and slotting it into place. We then reassemble the 3 V-rollers in exactly the same configuration as they came. Once they're finger tight, you can do them up. I recommend starting with the bottom V-roller and then doing the top 2. Check for wobble and then turn the eccentric nut on the lowest V-roller until there's no more play in your carriage. On the rear of the Hemera, insert another 2 square M3 nuts. We then take printed part B and align it with these 4 holes. You then use 4 M3x6mm bolts through the rear of part B and into the square nuts in the back of the Hemera. With this together, you should be able to see how it fits together with part A. On the rear of part A are 3 square nut traps. We're going to insert nuts into those as we go. Starting from the top, insert a square M3 nut into the nut trap and then use an M3x8mm bolt to go through and hold it in place. Align the 2 parts and then repeat for the lower left and lower right hand corners. Go around and ensure all 3 are tight and that there's no play in your assembly. To install the part cooling fan, we again insert square nuts into the outer edges of the Hemera, and then we use M3x10 bolts to hold the mount in place. To continue with the part cooling fan, we're going to have to liberate it from the wiring loom. Cut all of the cable ties that go from the old hot end to the main board and then undo the M2 bolts that hold the part cooling fan in place. Now we can pull back the protective sheathing and we'll have access to our fan. Make sure you've got the open end of the fan facing the inlet of the adapter and then use the shorter of the 2 M2 bolts to screw it into place. They'll cut their own thread on the way in. We can now take this sub-assembly, rotate it if necessary, and press it into place on the part cooling fan duct. If you're using a 50-15 fan, it'll obviously just go straight in. You're going to need 2 M4 bolts to hold this thing in place. One can be quite long and have a nut on the rear, the other one needs to be a specific length. I found M4x20 was spot on. Tighten up the mounts for the fan duct, but we're going to make a final adjustment later on. The old extruder and Bowden tube is sitting there doing nothing, so we're going to undo the 4 bolts on the top of it to remove it from the printer. Be sure to have your hand underneath the stepper motor, because when the last one comes out, the stepper motor will be free to drop and smash whatever's beneath it. Remove the old extruder and store it in a zip bag. If you're like me, your nozzle will be sitting way too low, so take the time now to manually level the bed, for now just using a piece of paper, but we can dial this in during our first print. Physical install done, so let's turn our attention to the wiring. Depending on your model of Ender 3, there'll be 3 bolts either on the top or the bottom to remove the cover to the electronics case. For standard they're on the top, for a pro you access this from the bottom. When you take the cover off, a fan will be plugged in, take care not to damage the wiring. We'll also need to remove the remaining bolts, top and bottom, and the 2 on the front corner to be able to remove the metal panel completely to access where the wiring loom enters the electronics box. Snip and remove the cable tie, holding all of the pieces of the loom together, and then carefully unwrap the cloth tape because we're going to recycle this later on. Follow the wiring down from the old hot end components and into the control box so you can separate it and see the wires that need to be undone. You'll need to remove the hot glue that's holding them in place before you attempt this. This diagram is linked in the description and highlights everything that needs to be unplugged at this stage. Here's all of the hot end components loosened, and finally the extruder being unplugged. Separate the blue and yellow part cooling fan wires and then use a cable wrap to finish off the new loom. At this stage, I chose to use a cable tie to tidy everything up at the Hemera end. Make this firm but not tight because we don't want to cut into the wires. Here is another diagram showcasing where everything needs to be plugged back in. Some of these have different connectors and colored wires, so we'll go through them one at a time. What was previously 2 red wires is now 2 yellow wires to go to the heater cartridge. There's 2 sets of red and black wires, and we're targeting the thicker of the 2, and that's the thermistor to be plugged in the corner. The skinnier red and black wires are meant to go into this screw terminal, but that's not going to work with the connector. So if we lift up the tabs and pull out the terminals, these crimp terminals should just have enough room to slide in, and when you tighten them, do not over tighten or you'll crush them and this will be irreversible. The blue and yellow part cooling fan plugs in exactly the same place as before. All that left for me was the extruder stepper motor cable, and it was too short, so I made up this simple extension loom. I carefully matched up the colors, plugged it into place, and then plugged it into the open spot on the motherboard. As you can see here, the red wire needs to be down in the corner. We can rewrap and re-cable tie all of the looms together where they enter the electronics box. After this, we can start to put the metal covers back on and screw them into place. But before we do up the second cover, I would recommend hot gluing the thermistor and stepper motor plug to avoid them coming loose. After this, you can put back on the final cover. We'll now tidy up our new loom, and I did this by moving the X-axis to its furthest extent and then cable tying the loom to the holes where the extruder stepper used to reside. Slowly move the carriage back and forth to make sure that the loom moves freely. We can now reapply cable ties to all of the ones we cut off when we were separating the original loom. This will keep our wiring tidy, but by far the most important one is the one down in the corner, and we want everything pointing to the side so when the bed moves back and forth on the y-axis, there's no collisions. Our physical install and wiring are done, apart from some firmware changes. On the Ender 3, you will need to burn a bootloader before you can change the firmware. I did just this and then downloaded and configured Marlin for Ender 3 as in this guide, except using the newest Marlin 2.0 as downloaded from their GitHub. Fortunately, the firmware changes required are quite brief. With our new all-metal hot end, we have a much higher maximum safe temp, so we're going to up that accordingly. We're going to search for max temp. Now to hot tighten, we need to go to 285, but from the LCD, it only lets us do 15 degrees below the max, therefore we'll need to put this up to 300. The thermistor in the new hot end is different to the old, so we're going to search for temp_sensor. And here for the top one, temp sensor 0, we're going to change that from a 1 to a 5. Next up, the new geared extruder will have different steps per millimeter. We're going to search for steps_per. And we get to our default axis steps per unit. And for the extruder, the baseline we're going to start with is 400. We will be tuning this to get it perfect later on. We just need it in the ballpark for now. Now optionally, if you're running auto bed leveling with the BL Touch, Easy ABL or anything else, you'll need to search for nozzle to probe offset and input the new values. You can also do this afterwards using the M851 command. If you're running an aftermarket board with smart TMC stepper motor drivers, you can update the current in configuration_adb.h by searching for axis_is_TMC and in brackets E0, and the new value is 940. With all of this done, you can compile and then upload. After uploading, the About menu from your LCD should have a much newer date and say Marlin 2.0 point something. Our sixth and final step is calibration, but it's actually a series of small items linked together. To help us fine tune, I highly recommend you download the program Printerface, which is free and lets us connect directly to the printer via USB. We're going to start with our final hot tighten of the nozzle, which means setting it to 285 and then leaving it for 5 to 10 minutes for all of the temperatures to stabilize. Now we can support the heater block with a large shifting spanner and then use a small spanner to tighten the nozzle against it. It doesn't need to be overly tight. When everything cools down, it will contract and lock everything into place. With this done, we can finally put on the silicone boot that covers the heater block and will protect our part cooling fan ducts from melting. Please wait for the hot end to cool down before attempting this. Now we're going to connect to the printer in Printerface and verify our settings are in effect. If we enter M503, it'll tell us our current settings. We can see that our E-steps are still at 93, and that's because they were stored in the EEPROM. We're going to overwrite this with M92 E400. You would have noticed after homing the printer that the nozzle no longer lines up with the corner of the bed. For me, I needed about 26mm on the y-axis to put it back in the correct position. Back in Printerface, this is an easy fix. We're going to enter M206 and then Y-26. Now after homing, the printer knows instead of being at 00, it's at 0-26 and will shift all of the print coordinates accordingly. You might notice that when you manually try and move your y-axis as far as it can go, it will now stop at 209. And yes, we have lost some print volume. The nozzle can no longer reach the very back of the bed without the Y carriage colliding with the frame. Our filament now feeds from the top, so if we remove the left-hand bolt from our filament spool holder, we can rotate the holder 90 degrees to orient the filament in the correct direction. Next is to trim down our PTFE tube, and I'm using a cutter to trim it just above the height of the wiring. That should keep everything clear of tangles. Time to load up some filament, so we're going to squeeze the lever arm. If we need to, we can make an adjustment on the dial for how tense the spring is underneath. Squeeze the lever arm with the nozzle up to temp, and then manually push the filament through until you feel it coming through the hot end. We're going to PID auto tune the heating of the hot end, and this is something I made a video about before, so I'll be really quick here. The command for this is M303 C8 S200 U1, and that's going to tune with 8 cycles at 200 degrees and save the results afterwards. When the tune is finished, you can turn off the heater and you can see it spat out our results here. And because we use the U option to save them along with our other settings we've done so far, we just need to enter M500. Next up is setting the amount of current that goes to the extruder stepper motor, and the value for this is provided by E3D. With the printer fully powered on and a multimeter set to DC voltage with a 2-volt limit, we're going to take the red probe, connect it to a small screwdriver with an alligator clip, take the black probe and touch it on the negative terminal where the power comes into the mainboard, and then put our connected mini screwdriver into the extruder trim pot. This diagram shows it a lot clearer, and our aim is to adjust it down to approximately 0.48 volts. We'll do our final tuning of the E-steps, and this is also something I've covered before, so we'll do it quickly here. With some light colored filament, we're going to get a ruler and mark 120mm above the end of our PTFE tubing. Back in Printerface, with the nozzle up to temp, we're going to set the distance and the speed at 100 and then click extrude. The marked filament will very slowly get drawn in, and afterwards you can measure the distance to the mark. You're aiming for 20mm, mine is 18, which means I over extruded by 2mm. So in summary, I wanted 100mm, I actually got 102, and my old E-steps were 400. Put these numbers into the formula and my new E-steps should be 392. Back in Printerface, I can enter M92, E392 for my new steps, press enter, and then M500 to save. Calibration is done, so let's tweak our slicer. There's really only two things we need to change. They should be pretty simple to find in any slicer. Firstly, now that we're direct drive, our attraction distance will be something like 1mm before we tune it. And secondly, we need to change our y-axis to be smaller, in my case to 0.9. Now this is a guide, not a review, but even so, I did print a couple of test pieces. This 20mm calibration cube is a direct comparison to when this printer was first assembled in a previous video. For the most part, it looks identical. I can't see any added ringing on the x-axis, which is where you would expect it to show up. The rest looks pretty much the same, save for some banding on the z-axis. I did accidentally leave the cover off the electronics and not have the fan blowing on the stepper motor drivers, so maybe that accounts for that. Now this printer does claim to be extremely good at flexibles, so I broke out some Filaflex. This is the softest and stretchiest TPU that I have, and I printed this low poly Fox at a base speed of 80mm per second, which for a filament this soft is really moving. To be honest, I was blown away by how well this came out. It smashed through the print, leaving a nice glossy surface, and as you can see when I compress the Fox, this filament really is soft. Despite this result, I'll be taking the Hemera off this printer and fitting it to another one, most likely the CR10 Max. It looks huge on an Ender 3, the mounting parts are also enormous, and I don't like losing that 26mm of Y volume. On the huge CR10 Max, with a 0.8mm nozzle and a slower print speed, it should get good results and mitigate the downsides of losing that print volume. I feel the actual Hemera extruder is a real work of art, but the implementation to fitting it to existing printers might be a little bit compromised. I think it's going to work best when it's printed to a fitter with carriages designed to take it directly. My patron Patrick has just completed this version on his CR10S Pro, complete with custom aluminium carriage, and I'm sure you'll agree this installation is very tidy. That's the end of my guide, but I'm interested to know your thoughts. Do you want one of these? Do you already have one? And if so, do you like it? Please leave your thoughts in the comments below. Thank you so much for watching, and until next time, happy 3D printing. G'day, it's Michael again. If you liked the video, then please click like. If you want to see more content like this in future, click subscribe, and make sure you click on the bell to receive every notification. If you really want to support the channel and see exclusive content, become a patron. Visit my Patreon page. See you next time.